Okay, so I think time to take a little look at this beauty that I picked up. I don't know what sort of state it's in. Just arrived yesterday, but as you can see, binocular microscope. I don't know that there's any. Yes, there is. This eyepiece is adjustable so that we can match up any imbalance in the eyes, so that's nice. I do have a couple of other lenses for it, but strangely one is about 4 inches long, and there's another one which is a times 20. These are times 8s that are fitted at the moment. So yeah, I've got two odd eyepiece lenses. So that might not be a huge problem if, for example, I was using one of them for a camera and the other one as a single eyepiece, of course. But yeah, that seems pretty good. Going over it, over here we've got an iris control. I haven't quite seen where that's joined up to. I think it's in here. We've got a diffuser. We're basically in or out. I can see down here a lamp source. On the left hand side we've got on off. And we've got a lamp brightness control. We've got a control for the, I can't think what this is called, stage, that would be the word. So control for the stage. We've got a control that brings the diffuser lens up and down to the stage. We've got an iris control under here for the actual condenser lens that's under here. We seem to have some sort of filters that can be clipped in. I'm not quite sure what they are. So these turn out not to be filters at all, but part of a phase contrast mechanism. So phase contrast works by the light which is coming from the tungsten, which is partially coherent, is focused onto a annular diaphragm. So this is a diaphragm that has multiple sort of concentric slits in it. And what I thought were filters are actually blocks that selectively box. So there are 3 slits in this particular one. And so one of them blocks 1 slit, one blocks 2 slits, one blocks 3 slits, and then there's also a setting that completely opens it up and it becomes a normal microscope. So those slits kind of control the light that is moving through the condenser through the specimen. Now the idea with phase contrast is that things like clear cells, for example, normally have to be stained, because if you shine a light through them you can't see them. But the idea is that if we control the light, then, for example, when it passes through different parts of the cell, they will have different diffraction and different ability to transmit the light. So because we have gained control of the light, then what will happen is that the light will become separated by the different densities in the actual cell, and things like the cell wall where it's actually vertical as opposed to horizontal. The result of that is that different parts of the light travel differently, and we can see that with a dotted line on the diagram here. And then that goes up, and prior to being seen by the eyepiece, is actually separated further by the phase plate, which is buried inside the objective lens assembly. So the result of this is that it highlights the different parts of the cell, but it has some downsides. It can make certain parts a little bit blurry. It can create halo effects and double exposure type effects in some places, because of course we've got multiple light paths. And we'll actually see that in some pictures that I put in a little bit later. Back to the microscope. There's an XY section on the stage, so we can move in any object, and the other lever moves us backwards and forwards. I noticed with the control for the height of this stage, which is also on this side, that it feels like there's a huge amount of slack, but in actual fact about a third of a turn, or maybe half a turn, is a very fine adjustment, maybe moving 0.5 millimeter, something like that, and then it switches into full speed mode and you can move it a long way. So that's really cool. So here we go. That's why there's 3 adjusters here, and quartz lamp Basically don't touch it, really, is what that boils down to. So yeah, fairly straightforward. Nothing iffy there. There we go. This is GS London, number 4672. So let's see what happens. Turn the bulb down minimum. Okay, well, we've got a lamp brightness control on this side. I don't see a lamp shining. The bulb has gone. This has got 1, 2, 3, 4, 5, 6 objectives on it. They look absolutely fine. Can't see any issues with any of those. So we've got some times 10s. The one that I want is no longer there. Right, great. Let's put that somewhere. So, okay, let's have a little look inside. Looking in the bottom, we've got a few interesting things going on here. So we've obviously got the mains cable coming in the back, and that doesn't actually go straight to the transformer. It goes past the transformer to the switch, obviously via the fuse. And then from the switch to this, and I'm going to say this is a rheostat. It might be configured as a pot, but as far as I can see, it's only got 2 connections to it. And this is then the output from this then goes back to the transformer's 240 volt tap. In the neutral, there was a little switch here which had me foxed for a while, but I think actually it is, or it was, a magnetic contact, because on the base plate there is a little magnetic strip. So this would disable this if you took the bottom off. That's been disabled by somebody. So anyway, yeah, so there we go. That's that. We get the switch, we get the rheostat. It goes back to the transformer, and then the transformer steps it down from to about 12 volt maximum. Now there is an adjustment on the knob of the rheostat to change the sweep, so you can't necessarily go all the way. So I've adjusted that so it goes from 0 volts up to about 12 instead of 6 volts to about 18, because I don't like to blow up the bulb. So yeah, so there we go. So let's have a little look now. So here we've got the bulb holder up here, and this is where the light comes, and the light travels forward from there, and this is a diaphragm and aperture, and it goes from there onwards to the mirror, and obviously then bounces up from the mirror and into the optical chain above with the condenser lens and all the stuff to do with the phase contrast and the optics and so on. Okay, so hopefully you can see here that there's an iris here, and I will adjust that, and that should show up. The lighting isn't the best, but it's probably about as good as I'm going to get for the minute. Yeah, so these are 3 adjuster knobs, and they change the attitude of the bulb. Yeah, there you go. It's just on a hinge. Well, and there we go, a bulb. Okay, so I found that an old box of stuff had the appropriate lamp in it. I should have looked through the big pile of stuff. I've got it turned down quite a long way because I don't want too much brightness for the moment. And we certainly have a lot of vibration. I'm just not quite sure which specific device that vibration is coming from. Now, there's a lot of adjustments as we move up towards this head, which is lying on its side at the moment. So here are the objective lenses here. Here's the XY table. Here is a filter set. And this is an iris control. Another iris control. So, okay, there we go. So I figure the first thing to adjust is this. So around here there are a whole series of little adjuster screws. So I've been adjusting that so that the condenser lens, which is just in here, is lined up as well as I can with the objective lens. Now if we then go around to the bottom here, we can actually see projected on the bottom of whatever that is the element of the light bulb being projected onto the bottom of what is in actual fact a filter. You can actually see the filter there moving out the way, and behind it you can just see there's a target. So if I turn this way, there's a smaller sort of filtered area, and turn this way and there's 0. So these are the different filter positions essentially. So there's a blue, I think there's a blue, green and a nothingness. And so what I need to do now I've got those sorted is to ensure that the light is falling well onto the mirror, which it is, and it's projected up directly into the centre of that little target. Okay, so here we go, we're up and running. I have things adequately aligned, not wonderfully aligned to be perfectly honest. So hi, I thought it would be useful to just finish off this section on the microscope by actually joining up a camera. So this is Ekin's sort of industrial camera. It's got a C mount on it, and it's easy to get a C to microscope. So the microscope I think is 23mm, and you can get a C mount that plugs directly in, and generally speaking they have a 0.5 times magnifier in there, because obviously displaying it on the screen is going to magnify it quite a lot. So let's turn around and have a look at the screen. I will try and take a few screenshots of this to help you. Let's have a little look at something that we might be interested in. So this is on its times 10 objective. If we just move across to let's say times 40, yep, and here we can see stuff now. The problem is how to focus the actual camera, whereabouts to focus it. So and here we go, and there we go, we are now looking at the scales of a butterfly's wing. So I don't know again whether or not we can highlight that better if we use a different filter. Yep, a little bit I think. Okay, so this is some bone cells. And yeah, up into this little cluster here and turn the magnification up. There we go. Yep, okay. So you saw it here first. So skin, essentially, of onion there. And it's pretty clear on that setting. Pretty good on that one as well. So you can see the phase difference and effect here quite clearly. On this one we can really just see the edges of the cells rather than the and some of the wider patterning. Whereas in this one, for example, we can see some stuff more clearly. Now if I adjust the aperture underneath the lens, then for some of the stuff, particularly on the right hand side, it sharpens up a bit. Now the reason it's on the right hand side is because this isn't perfectly aligned at the moment. Adjustments, we can kind of see some variation happening a little bit, but yeah, okay, pretty damn good. And this gives us a chance to see the ability to run along. Okay. So quite like that. Let's zoom in a bit more on that one. Yeah, so there we go, this is pretty good. And again, we can change our aperture here. Okay, and zooming in on this last 100. Okay, and I couldn't really finish without popping this one on the screen. So, anyone want to make any guesses? I'm going to spoil it for you now. This is fish testicle. So this is a cross section through it, or a very ultra thin slice. But yep, you are looking at the testicles of a fish. So anyway, don't get carried away. But that's just on ×10 magnification. Let's pop it up to our usual ×40, which is probably the magnification I like most, I suspect. So there we go. With that exciting finish, I'm just going to show some of the pictures that I've taken from the microscope over the last sort of hour. And we've got various things here, but hope you enjoyed that, and hope you also learned something about phase contrast microscopes and the way they work. I'll put some links in below, which will hopefully lead you to a better explanation than I can give, because, you know, my skill with the microscope is not that great, but I'm really pleased to have got this one up and running. I've certainly got a little bit of work to do just to get rid of that annoying buzzing sound, which I suspect will be the transformer, unfortunately. But there's a few options available there, possibly putting some solid state control in, for example. We'll see what I get up to, probably in a later video. But if you enjoyed this, please give that a thumbs up, or share it with your friends. Please subscribe if you haven't already done so, and of course you can leave comments or questions below. I'll put in a few useful links, and I'll see you next time. Take care.